So the next topic has to do with functions that are not typical. Usually when you have a function, it looks like this. Usually your function is just f of x equal to whatever. So y equal to whatever. Where this one is a term of x, like you have x squared plus 5x, you have 2x plus log of x plus sine x or whatever. But usually you have f on one side and x on the other side. You have y on one side and x on the other side. However, sometimes things might not be that simple. Sometimes you have functions that x and y kind of got mixed up. Like in this one, you cannot rewrite this function as y equal to something x because you have x plus y equal to sine of y. There's no way you can solve for y in terms of x. But I want to find the derivative of this function. So basically, the notation for that dy by dx, this is the same as y prime. It's the same as y prime of x. So this all refer to the derivative, by the way. So but the notation dy by dx is going to be more convenient to use. So that's why we use this one for now. So when you have a function where x and y kind of got mixed up together, these kind of things are called implicit functions. And there are steps that you can use to find dy by dx or to find the derivative for this guy. Before I go ahead and show you the example, let me actually just write down the principle first. So there are 3 steps that you can do. There are 3 steps that you can do. The first one is that you take derivative of everything. With respect to x. Then keep in mind that whenever there is y, that its derivative will have the term dy by dx. And also, you separate all the terms that have dy by dx to one side. So these are the steps that we can use to find the derivative of the implicit function. So let me actually show you in the example here. So I want to find the derivative of this guy x plus y equal to sine of y. So I'm just going to do what I just written down. I'm just going to take the derivative of the whole thing with respect to x. What is the derivative of x with respect to x? Derivative of x is going to be just 1. So derivative of x becomes just 1. What is the derivative of y? Well, you can think of this just as similar to the chain rule. Derivative of y with respect to x is going to be just dy by dx. So that's the usual derivative. So whenever there is a y, the derivative will involve dy by dx. In this case, it's just a simple y. So derivative of y is just dy by dx. Now, what is the derivative of sine of y? You can think of this as the chain rule. Derivative of sine of y, derivative of sine is cosine. So derivative of sine of x is cosine of x. Derivative of sine of y is going to be just cosine of y. However, because this is the y, not the x, so its derivative is going to have another term dy by dx. So that's what I mean when I say whenever there is a y in the term, the derivative is going to have to involve the term dy by dx. So that's going to be multiplied to whatever your derivative is. So what I have written down up here, this is basically just a version of a chain rule. If your function is f of y, the derivative of that is going to be just, if you use chain rule, it's going to be just f prime of y, the derivative, times dy by dx. So that's what's going on here. Derivative of sine is cosine, so derivative of sine of y is cosine of y. But because you cannot take derivative with respect to x, so you should have dy by dx, another extra term coming along. So that's my step 2. My step 3, I'm going to separate all dy by dx to one side. So let me do that here. Let me move dy by dx to the left hand side. So dy by dx minus cosine of y dy by dx is negative 1. I pull off the dy by dx, so I'm going to get dy by dx times 1 minus cosine of y equal to negative 1. So now I can move cosine of y to the other side, so I'm going to end up just having dy by dx, which is the derivative that I ultimately want. It's going to be just the quotient, negative 1, over 1 minus cosine of y. And that would be my final answer. So once again, the step for finding the derivative of the implicit function is this. You do step 1, so it's step by step. You take the derivative of the whole function with respect to x. Then whenever there is a y, keep in mind that the derivative is going to have to involve dy by dx. So that's like what I have here and here. You separate dy by dx to one side, that's like what I do here. And once you do that, you pull out the common factor, which is a factor, yes? You pull out the common factor dy by dx, and then you divide whatever that is left to the other side. So you end up having dy by dx equal to your answer. So it's not that bad. Let me try again. My second function is 2 to the 3y plus x squared equal to y squared. Once again, this is an implicit function. There's no easy way I can separate the x from the y and just take derivative. So I'm gonna have to use the implicit differentiation. So I will do what I said I will do. I take derivative of the whole thing. 2 to the 3y, I'm gonna have to use a chain rule again here. So derivative of 2 to the 3y is gonna be log of 2 times 2 to the 3y. Now, because it's 2 to the 3y, the derivative of exponential function is gonna be log of 2. and 2 to the 3y stay the same. However, because the numerator, the exponent is 3y, so when I use the chain rule here, I'm gonna need to multiply this guy by the derivative of my things, which is my 3y. I have to take derivative of my inside function. Derivative of 3y is gonna be 3 dy dx. So again, the dy dx come along. The 3 come from the derivative of 3y. So that's the derivative of my first term. My second term, this is just the x. The derivative of x squared is just going to be 2x. So if there is no y, things are pretty simple. And for the last term, the derivative of y squared, that's going to be the derivative of y squared is going to be 2y dy dx. So again, whenever you see the y, you treat it just what you would do to the x function, but you will end up having the extra term of dy dx. And I go into my routine again. I just separate dy by dx to one side and then put everything else to the other side. So I'm gonna have log of 2 times 2 to the 3y times y times dy dx minus 2y dy dx on one side. And then negative 2x on the other side. I pull off the common factor, which is going to be dy dx. So that thing is going to be the same as dy dx times this whole chunk. Log of 2 times 2 to the 3y times 3 minus 2y. And now I move this whole chunk to the other side. I'm going to get my final answer, dy by dx. That's going to be negative 2x all over that whole thing. Log of 2 to the 3y times 3 minus 2y. And that would be my final answer. So again, from the beginning, this function is not a simple function. It's not a function of y in terms of x. So I have to use my implicit differentiation. When I use implicit differentiation, the first term, this is a little complicated. So I use chain rule. It's going to end up having dy by dx. X squared becomes just 2x. Y squared becomes 2y dy dx. I move all the terms with dy dx to one side. I pull out the factor dy dx and I divide by whatever that is left to the other side, and that is going to be my final answer.